Good morning. Hello friends. Last video we tried to understand about the slope detector. Now in this video we will try to understand about the balanced slope detector. As we have seen in previous session that the slope detector having some of the drawbacks. Now with the help of balanced slope detector these drawbacks can be reduced up to some extent. So let's try to understand what is there in the balanced slope detector. Now basically the balanced slope detector is the improved version of the slope detector, where the drawbacks of harmonic distortion in slope detector is reduced with the help of balanced slope detector, as well as the balanced slope detector is used to overcome all the drawbacks that what we have seen in generalized or in a simple slope detector. The one more important fact concerned with the balanced slope detector is that it is used to basically increase the range of linearity, which was the main concern in the simple slope detector method or in the slope detector approach that what we have seen in last video. So let's first of all quickly just check out the circuit diagram for the balanced slope detector. The balanced slope detector, also called as the balanced frequency discriminator. Now if you, as you can see here in the circuit diagram, we are having the two tune circuits here. So the first tune circuit which you can observe here, and the second tune circuit which you can observe here. So basically in the balanced slope detector we are using the two slope detectors. Again you can identify here as we are talking here concerned with the two slope detectors. So here the transformer that is going to be used, that is the center tap transformer that what we have, and here you may find the primary winding at the input side, and the second side you may observe the secondary winding with the center tap. So here in the whole circuit you may find there are the two diodes, there are the two RC filters which we are observing, having R1 C1, the output for which we are considering as in V1 and VO1, and for the second slope detector the filter which is considering as in with the help of R2 C2, having the output V2. So basically if you observe the overall circuit diagram, so if you can see the input which is going to provide here, that is will be our FM signal, and the FM signal which we are going to provide as an input at this point, that may have the center frequency FC, or we may call it as in the carrier frequency what it may have. Now the two frequencies are here produced by the secondary winding. Now the first one will be the FC plus delta F, and the second one will be the FC minus delta F, and in this regard we are observing these two output, VO1 and VO2. The overall output here what we are observing as VO, so the overall output VO will be the combination of these two observe output VO1 and VO2, and it will be VO1 minus VO2. Okay, now to understand further operation of this balanced loop detector, so we just need to understand with the help of certain conditions. So we will talk about one by one condition which going to be which is going to help us to understand the operation of this particular balanced loop detector. Now let's consider the condition number 1, where we may have F in which is equal to the FC. F in which is equal to FC. Nothing but the here we may say F in is nothing but our FM signal frequency, right? Now if you observe here in the circuit, so we may find that in this particular case of F in equal to FC, the two transformer that what we are observing here as a T1 and T2, which is secondary winding basically, so they will have the same voltage. So both this transformer, they will have the same voltage, and therefore these two diode, so the diode D1 and the diode D2, they are going to conduct at the same voltage, and therefore the VO1 and VO2 will be same, right? But observing the polarity in this particular case, we may find as VO1 and VO2 will be same, therefore the final output VO in this case will be 0. So this will be the first case, right? Now we will consider the case number 2, where we may find the FC which is less than F in. Okay, now nothing but the which is less than FC plus delta F. So this is our second condition. So this is the second condition, right? Now here in condition number 2, what we can see, okay, here in condition number 2, if you again going to observe the circuit diagram, so you will find you will find that here the T1 is going to work more, or T1 will conduct, means T1 will have the more voltage level compared to the T2, and in this case the D1 will conduct more. Therefore the output what I am getting here, which is VO1, that will be the positive. And as the T2 voltage will be less compared to the T1, so therefore the diode D2 will conduct less, and this VO2 will be negative, and therefore the output VO, which I'll get in this particular case for condition number 2, that will be my VO will be positive. Right, so this is my second case. Now again, if I just check here the third case, where I may consider, or I may observe as FC, which is less than Fin, which is greater than Fin, nothing but the FC minus delta F. Okay, so simply my FC is greater than F minimum. So if you again going to identify the circuit condition here, so you will see here, now in this case the T2 voltage will be more compared to the T1, and in this case D2 will conduct more, and therefore my VO2 will be the positive, and my VO1 will be less compared to the VO2, and therefore in this particular case I may find that my VO, which is my actual output of the circuit, that will be negative. So therefore in case number 3, VO, which is my output, that is basically negative. So this is the case number 3. Now if you just see one more condition, which I may say the condition number 4, where simply if I find the frequency range which is I am considering over here, if that goes beyond that, or if it goes out of the range, nothing but the, I may say, if it goes beyond the range which we are considering as FC plus delta F to FC minus delta F, nothing but the F max to F min, or F min to F max. Okay, so in this case if I just check my output, in this case my output will be null, so means my voltage will, output voltage will fall, right? So that is the thing that what I may observe over here. Now again, from the characteristic point of view, if I just need to understand further, right? So basically the characteristic which we observe for the balance modulator, so that is observed in this particular form. Okay, so where the where the basically if you see for the frequency which is observed to be as fc plus delta f, or basically first of all if you just check the x-axis which is showing here, that is the frequency, and the y-axis which is shown here, that is our voltage range, or basically our output voltage, that what we are observing, right? So this particular characteristic, so if you just find or just try to understand the range which is between fc plus delta f and fc minus delta f, so we will find, okay, so it's totally the linear kind of the characteristic that what we are basically observing now. So if you just check here at f max, where we may have the frequency fc plus delta f, where we have considered this particular condition, okay, which we have discussed earlier. So in that case we have seen already that fc is less than fin, and in that case d1 and d1 voltage is greater than d2 voltage, therefore v1 is greater compared to the v2, therefore my VO is positive. And just the first condition that what we have seen here, where we identify fin which is equal to the fc, where both diodes they conduct at equal voltages, therefore the output which they provide, VO1 and VO2, they are equal, and therefore the VO is going to be 0. And where the other side, where we consider the frequency f mean, where we generally observe fc minus delta f, where fin is less than fc, so where d1 voltage is greater than the d2 voltage, therefore the the d2 voltage is greater than d1 voltage, therefore the v2 voltage will be more compared to the VO1 voltage, and therefore my output will be negative. So this particular output characteristic is also called as the S-shaped characteristic, as it look like the letter S. Now concerned with this particular characteristic, we need to understand the basic fact, okay, when we consider the characteristic of any circuitry, okay, so when we generally talk about the bandwidth, so for example, let's say if you are just considering here, so let's say if for fc plus delta f, so observing this particular like this, okay, so for let's say for fc plus delta f, okay, so maybe for f max, so that is observed in this particular form, okay, and similarly on the negative part, so this will go something like this, right? So here also I will have this particular f mean. So any characteristic, okay, of circuit which we generally observe. So we basically observe it at the 3 dB point. Okay, so if you just consider here, so at fc plus delta f, so at this particular value, so below the 3 dB point, so we may observe here as like this, and this overall total range, okay, that is what we called as bandwidth, so which is observed as 2b. Which is observed as 2b. Okay, so on another side, so similarly we may also have here the so here also we will get this 2b, so that will be the bandwidth. But the bandwidth what we consider here, so let's say if as this is the 2b overall, so this particular part, okay, so this particular part will be the b. Okay, similarly here also, so this particular part, okay, so this is the b, and the useful range that which is over here, so what we observe, right, so that is also the b. So the overall linearity range that what we observe here, or the particular linearity range, we may get the bandwidth for 3b, so which is basically the my useful frequency. So this is the basically advantage with the help of balance slope detector, where we basically going to increase the linearity range of the particular circuitry. So basically again there are drawbacks. There's a difficult basically to tune the there is basically difficulty to tune these tune circuits, because this particular balance modulator having more number of tune circuit, so which are basically used at different frequencies. The one more important thing is that, which is again a drawback, so where this particular useful range what we are having here, so that's basically for some amplitude limiting condition is there. So basically amplitude limiting condition is not provided over here, so that is restricted, and this particular linear characteristic is also limited to the very small frequency deviation. So these are the drawbacks what we generally observe in the balance slope detector. Now, the advantageous part is that it is more efficient compared with the simple slope detector, as well as the linearity is much better compared with the simple slope detector. So just